In this set of videos, we're going to be looking at Lesson 2 of Unit 5, and we are going to be asked to analyze arithmetic sequences and series. Definition of an arithmetic sequence you see listed here. In an arithmetic sequence, the difference of consecutive terms is constant. Now, this constant difference is called the common difference and is denoted by the letter D, or the variable D. When we talk about arithmetic sequence, a constant difference means that we continue to add the same number over and over and over again as we move from term to term. For example, tell whether the sequence is arithmetic or not. Well, looking at this first one, to go from 7 to 13, I add 6. To go from 13 to 19, I add 6, and from 19 to 25, I add 6 again. I would go ahead and be willing to say that yes, this is arithmetic. So in the explain why part, we're adding 6 each time. You can make a note of that, that'd be fine. I have a common difference of 6. Second series or sequence, is this arithmetic? -8 to -4, well, that's a difference of 4. -4 to 0 is a difference of 4. Oh, great. But if we stop there, we'd be wrong because the next difference is 6. From 0 to 6, I have a difference of 6, and from 6 to 12, I go up by 6 again. So here's 4, here's 4, but then from 0 to 6 is 6, and from 6 to 12 is 6. Because this isn't the same, it doesn't stay constant the whole time, this would not be arithmetic in nature. Okay? Now, writing a rule for an arithmetic sequence. So if I'm going to write a rule for this, in general, to find the nth term of an arithmetic sequence for the first term a sub 1 and the common difference d, we're going to write it this way. To find the nth term, I would take the first term, whatever it happens to be, plus n minus 1, n again being the number of terms, times the common difference, which is d. So if I start with 7 and I add 6 over and over again, the rule I would write for this function would start out as a sub n is equal to 7, the first term, plus n minus 1, and again, a number of terms, times d, the common difference, which happens to be 6. Now, typically, you won't leave it in this format. You'd probably distribute the 6 and then clean it up a little bit. To show you what that looks like when we're all done, if I distribute the 6, I have 6n minus 6. There was a 7 here that I was adding to these expressions. The 7 and the -6 go together, so in the end, the rule for that particular function would be 6n plus 1. There would be an explicit formula that gives me the terms of this sequence. Another example we have here, if I have the first term of 2 and a common difference of 3. Okay, same thing. To find a sub n, I take the first term, which is 2, plus n minus 1 times the common difference, in this case, which is 3. Clean it up, distribute, and I get 3n minus 3. So we have 2 plus 3n minus 3. The 2 and the -3 go together, and that becomes -1. So in the end, we've got a sub n. To find the nth term, I take 3 times n minus 1. Here's my arithmetic sequence rule. Let's practice a couple more here. Write a rule for the nth term of the sequence. All right, -7, -10, -3, -16. Looks like this common difference is -3 because I'm going down by 3 each time. So when I write these rules, there's two things I need to know. I need to know the first term, and I need to know the common difference. Well, the first term in this case is -7, and the common difference is -3. Well, that's it. I'm going to put in the right spots in my formula. To find the nth term, I take the first term plus n minus 1 times the common difference d, I'll put it in parentheses, -3. And then let's clean it up some. Distribute the -3. We've got -3n plus 3. Remember, we had a -7 out in front of all this. So when I put those things together, the -7 and the +3 are going to add up to -4. So to find the nth term of this sequence, we're going to take -3 times n minus 4. Here's my rule. The other thing we're asked to do is we're asked to also find a sub 20. Well, that would be the 20th term. So to find the 20th term, because I have this nice explicit rule, I can take 20 and plug it in. -3 times 20 is -60. -60 minus 4 is going to be negative. 64. So that's what the 20th term in that particular sequence would be. And the next example, 59 to 68, 77 to 86. Looks like we've got a common difference of 9. Add 9, add 9, add 9. First term is 59. So to write out my rule, the nth term is equal to the first term, 59, plus n minus 1 times the common difference, which is 9. Clean it up. Distribute. 9n minus 9. Add that 59 that was out in front. 59 minus 9 is 50. So in the end, find the nth term of this sequence. I take 9 times n and I add 50. And finding the 20th term means take 20 and plug it in. 20 times 9 is 180. 180 plus 50 would be 230. There's the two parts to my answer. Very nice.